Hey there, curious minds, and welcome back to What Is. Today, we're soaring beyond the clouds, past the atmosphere, and straight into a question that once launched an entire generation's dreams. What is a space shuttle? Now, when you picture space travel, you might think of sleek rockets blasting off, or perhaps futuristic starships zipping through hyperspace. But for 30 years, the icon of human spaceflight was something far more remarkable. And, frankly, a bit more like a very sophisticated, incredibly fast, unpowered brick with wings. At its core, the Space Shuttle was a complex, partially reusable orbital spacecraft system. Imagine an airplane that could fly into space, deliver cargo, pick up astronauts, and then glide back down to land on a runway. That was the dream. It wasn't just one vehicle, though. It was a trio of components. The majestic winged orbiter itself, which housed the crew and cargo, a massive external tank filled with propellants, and two mighty solid rocket boosters strapped to its sides, providing the initial thunderous push to orbit. So, where did this audacious idea come from? Well, after the triumphant Apollo moon landings of the 1960s, NASA and the US government faced a dilemma. The powerful Saturn V rockets were incredibly effective, but also incredibly expensive and entirely expendable. Each launch was a brand new rocket. President Nixon's administration, looking for a more economical and routine way to access space, challenged NASA to design a new generation of space vehicles. The vision was clear: a reusable space truck that could ferry people and payloads to low Earth orbit, reducing costs and increasing mission frequency. Easier said than done. The journey from concept to launch was a colossal undertaking, filled with engineering nightmares and political tightropes. Designers wrestled with the seemingly contradictory goals: a craft that could withstand the fiery inferno of re-entry, function in the vacuum of space, and yet, somehow, land like an airplane. Early concepts ranged from fully reusable two-stage designs to more modest, partly expendable options. What we got was a compromise, a marvel of engineering born from necessity and innovation. Engineers spent years figuring out how to protect the orbiter from the insane temperatures of re-entry, thousands of individually placed ceramic tiles, forming a cosmic jigsaw puzzle, each one vital. It was, shall we say, a high-stakes game of Tetris, with extreme consequences. Finally, after years of development, billions of dollars, and countless sleepless nights for thousands of engineers, pilots, and scientists, the Space Shuttle Columbia roared to life on April 12, 1981. Piloted by astronauts John Young and Robert Crippen, it was the dawn of a new era. The promise of reusability was real. The orbiter, named Enterprise, had already performed atmospheric test flights. But Columbia's mission, STS-1, was the first time an entire, integrated space shuttle system would truly fly into space and return. And it did, gliding down to Edwards Air Force Base like a massive, very warm, and utterly triumphant glider. Over its 3-decade career, the Space Shuttle became the workhorse of American spaceflight. It deployed satellites, retrieved others, and even repaired the legendary Hubble Space Telescope, a mission that truly showcased the unique capabilities of its robotic arm and human ingenuity in orbit. It was instrumental in building the International Space Station, carrying up module after module, piece by painstaking piece, effectively constructing humanity's orbiting home. Astronauts conducted experiments, lived and worked in microgravity, and looked back at our pale blue dot, forever changing our perspective. Of course, such ambitious endeavors come with immense risks. The shuttle program experienced 2 devastating tragedies: the loss of Challenger in 1986, and Columbia in 2003. Stark reminders of the inherent dangers of pushing the boundaries of human exploration. Each loss was a profound blow, but also a catalyst for learning, for improving safety, and for honoring the brave souls who dared to fly. By 2011, after 135 missions, the Space Shuttle program concluded. Its legacy, however, is anything but. It taught us invaluable lessons about reusable spacecraft, heavy lift capabilities, and the complexities of human spaceflight. It bridged the gap between the Apollo era and the burgeoning commercial space industry of today, inspiring new generations of engineers and entrepreneurs. Many of the technologies, the mission profiles, and even the sheer audacious spirit of the Space Shuttle live on in the rockets and spacecraft now pushing towards the Moon and Mars. So, what is a Space Shuttle? It was a marvel of engineering, a bold experiment in reusability, a symbol of human ambition, and a testament to what we can achieve when we dare to look up and reach for the stars. What other marvels of engineering or scientific phenomena should we explore next? Let us know in the comments below. If you enjoyed this journey into the wild world of the Space Shuttle, hit that like button, subscribe to What Is for more fascinating deep dives, and don't forget to ring that notification bell so you never miss an adventure. Thanks for watching, and we'll see you in the next one.